In this question, you have to find which of these graphs is represented by this. Note that here x is given in terms of y. The value of x is mod of mod y minus 1 then plus 1. If the question is not clear, I have written the question once again. It is clear that these two graphs are not possible because from the equation it is clear that because this is a positive quantity, the value of x is sure to be greater than or equal to 1. The value of x can never be less than 1, and here according to this graph the value of x can be 0 also. According to this graph the value of x can be negative also for this portion. And now we have to select the correct one out of C and D only. Now let us find the point where the graph cuts x-axis. For that, put y equal 0, and putting y equal 0, the value of x comes to be 1. Hence the point where the graph cuts x-axis is sure to be 1 and 1. And from this graph, again it is clear that this graph is not possible because according to this graph, in this portion the value of x is less than 1. But it is clear that the value of x can never be less than 1. Hence, this is the correct graph. In this question, it is given that p is a polynomial of degree 3 whose graph is given as this. Using both these informations, you have to get the value of p minus 2 and the formula for px. Assume that p minus 2 is integer. From the graph, it is clear that the roots are minus 4, 0 and 3. Hence, I can say px is x minus minus 4, x minus 0 into x minus 3 and whole into a, where a is a negative number. How can I say a is a negative number? Because the graph is coming from up and going below. If you have attended my video lecture of graph, I have given complete explanation in that graph. And it is also clear from the graph that for x equal to minus 2, the value of y is minus 1. That is p minus 2 equal to minus 1. Using this in this portion, I can get the value of a as minus 1 by 20. And finally, you have got the value of px as this thing. And from here, I can easily find the value. In this question, he is telling us to draw the graph of y equal to 2 tan x by 2 upon 1 minus tan square x by 2. Note that it's not difficult to see that this is same as tan x. It is a formula of trigonometry. But note that for x equal to pi, 3 pi, 5 pi, etc., at those points it will be undefined. But at pi, 3 pi, 5 pi, this will be defined. Hence, we can say that when x is odd multiple of pi, at those points, this is not same as this. But for all other values of x, this is same as this. Hence, to draw the graph of this, we draw the graph of this, but from that graph, we'll be rejecting those points where x is odd multiple of pi. That is why I can say this is the graph. This is the graph of tan x, and this is the second branch. It is passing through pi, but this point will be rejected because actually we are drawing the graph of this. For this graph, continuous curve will come, but for this graph, this point will not be lying on the curve. Therefore, I have drawn a empty circle. You must be knowing the meaning of empty circle. This empty circle is also called puncture. Similarly, for minus pi also it is undefined. In this question, it is told to us to draw the graph of y equal to log tan x plus log cot x. Given equation clearly can be written as y equal to log of tan x into cot x, that is log 1, and log 1 is 0. But this thing is also be taken care of that this equality is possible only if both tan x and cot x are positive. Hence the allowed values of x are 0 to pi by 2 or pi to 3 pi by 2 or 2 pi to 5 pi by 2 and so on. Or if we go in negative side, then minus pi to minus pi by 2, minus 2 pi to minus 3 pi by 2 and so on. That is for these values of x, the value of y will be 0. Hence the graph will be this, shown by red line. Here empty circles are drawn because exactly at these points the function is undefined. That is, exactly these points do not lie on the curve. In this question, he is telling us to draw the graph of y equal to sine square x and y equal to under root sine x. But for clarity purpose, I will be drawing the graph of y equal to sine x also in the same coordinate plane. The graph of y equal to sine x, you must be knowing, is shown by the red line curve. You must be knowing it. And you know that for the values of x, when sin x lies between 0 and 1, the value of sin square x will be less than the value of sin x, because for a number which is less than 1, for example 1 by 2, 1 by 2 square is less than 1 by 2. That is for the value of x between 0 and pi. Red line is a graph of sin x, then black line will be representing the graph of y equal to sin square x. For example, under root 1 by 2 is more than 1 by 2. For the values of x between 0 and pi, the value of under root sin x will be more than sin x. Therefore, the graph up will be represented by the green curve. Agreed at maximum point, both have given same result. Maximum point is lying on all the three curves. And second thing is, the graph of sin square x cannot go below x-axis. It will be remaining in upper portion only. And for the values of x, when sin x is negative, in that case it is undefined. Therefore, between pi and 2 pi, there is no any graph of under root sin x. In this question, he is saying that given below is the graph of y equal to fx, find the graph of y equal to minus fx. It is clear that for these values of x, y is positive. And in this graph, therefore, this portion will come below, this lower portion has gone up. Similarly, this lower portion has gone up. This is the graph of y equal to minus fx. In this question, it is given that the graph of y equal to fx is this. You have to draw the graph of y equal to mod fx. It is clear that for the values of x for which fx is positive, that is y is positive, for those values of x, the graph of this and the graph of this will remain same, because mod fx will become fx when fx is positive. For the values of x for which y will be negative, that is fx will be negative, at that time mod fx will become minus fx, that is y equal to minus fx. You will be getting same numbers with opposite sign. That is, this portion will come above x-axis. That is, remember that whenever you have to draw the graph of mod fx from fx, the upper portion remains same and the lower portion of the graph is always reflected above x-axis. This is the graph. In this question, it is given that the graph of y equal to fx is this. You have to draw the graph of y equal to mod fx minus 1. It is known to us that to draw the graph of y equal to mod fx, just keep the graph of y equal to fx which is lying above x-axis as it is, and take the reflection of lower part of the graph in x-axis, that will come up. That is, the graph of y equal to mod fx will be this. And once we have drawn the graph of y equal to mod fx, to draw the graph of y equal to mod fx minus 1, obviously just take the graph of this below x-axis by 1 unit because it is minus 1 here. Hence this portion will come here where the height is 1. This portion will come below at this point here. This point will come here. And this point will has y coordinate 2, it will be coming here. And you have got the graph of y equal to mod fx minus 1. In this question, you are given the graph of y equal to fx and you have to draw the graph of y equal to mod of fx minus 1. It is clear that to draw the graph of y equal to mod of x minus 1, first of all we draw the graph of y equal to fx. And after this we draw the graph of y equal to mod fx. And from here we draw the graph of this. It is not necessary to take this route. We can take this route also. From the graph of y equal to fx, we draw the graph of y equal to fx minus 1. And after this, we draw the graph of this. Both the routes are equally good. The point we noted is to draw the graph of fx minus 1 from fx. This is applicable for every question. That is, I mean, whenever the graph of y equal to hx is known to you and you have to draw the graph of hx minus lambda, if lambda is positive, then simply shift the graph of y equal to hx on right hand side by lambda units. And if lambda is negative, in that case, shift the graph of y equal to hx on left hand side by lambda units. Here I have taken this route, that from here I am drawing the graph of this and from here I am drawing the graph of this. This is obvious that the graph of this will be this. You must be knowing, otherwise this thing I have explained in previous videos also, that take reflection in x-axis of the portion lying below x-axis. And to draw the graph of this from here, shift the graph of this by 1 unit on right hand side. That is this point, which is 1 2, that will become 2 2. The point 30 will become the point 40. Hence we have got the graph of y equal to mod fx minus 1. In this question he is saying that given below is the graph of y equal to fx, find the graph of y equal to f mod x. You must know that if the graph of y equal to fx is known to you and you have to draw the graph of f mod x, this concept is applicable for every graph, that in the graph of y equal to fx, reject the portion on left hand side, and next step will be take the reflection of graph lying on right hand side in y axis. That is, this complete will be the graph of y equal to f mod x. And obviously this has to happen because for the values of x, say 1 2 3 4 etc., and for the value of x, say -1 -2 -3 -4, the value of y is going to be same. That is why the graph of f mod x will be this. In this graph, the left hand side portion will be rejected because left hand side portion is coming when f operates upon a negative number. But here f will not get chance to operate upon a negative number. X can be negative, but mod x is sure to be positive. Therefore, for x equal to 2 or -2, value of y is going to be same. For value of x 3 or -3, value of y is going to be same. That is why the graph will be simply mirror image in y axis of the portion lying on right hand side.